Hello everyone. How are we doing today? Okay, so this is the second part of our chapter 4 homework. Okay, and we are talking about the Le Chatelier's principle. Remember, you guys know what is Le Chatelier's principle. Can somebody tell me what is the Le Chatelier's principle? So, this chapter 4 homework is all based on Le Chatelier's principle. So, if you have forgotten about it, we do have it written down in your PowerPoint slides, and also we explain it in our video. So what it says is, when a chemical system at equilibrium is disturbed, it reattains equilibrium by undergoing a net reaction that reduces the effect of the disturbance. Okay, so when do we disturb a system? Excuse me. So system can be disturbed when there is a change in conditions. Forces it temporarily to out of equilibrium. So what it does is, it would adjust itself. Either it goes to the forward direction or the reverse direction and come back to the equilibrium again. So the equilibrium position changes, but the equilibrium constant doesn't change by changing the pressure, volume, number of moles, or the concentration. Okay, but if you change the temperature, then the equilibrium constant can change. Okay, the only way that the equilibrium constant change is that by changing the temperature. Otherwise, if you do a change with concentration, pressure, volume, number of moles, what happens is, it by either going the forward direction or reverse direction, equilibrium, the position of the equilibrium shifts, but the equilibrium constant doesn't change, because it would readjust to get the same Kc, same ratio of the products to reactants. Okay, concentrations may change, but the ratio doesn't change. Now in this questions from 10 to 15, we're going to see how the change in temperature changes the equilibrium, which direction should it move, and also what happened to the equilibrium constant, whether it's going to get a bigger equilibrium constant or a smaller one by going through some temperature changes. Okay, you guys ready? Okay, so the next one, let's look at here. Let's look at number 10. The reaction of nitric acid to form dinitrogen oxide and nitrogen dioxide is exothermic. And we talk about in our lecture videos, and also you guys know about what is exothermic. Exothermic is in a reaction that you generate heat, and we talk about that heat can be considered as a product, right? Where is, okay, right here. So heat can be considered as a product. So that's why you see in an exothermic reaction, heat is a product. What effect will be seen if the temperature of the system at equilibrium is raised by 25 degrees Celsius? So now we are giving, or we are increasing whatever the temperature it is there, we are increasing it by 25 degrees Celsius. We are adding heat. So if you add heat, are we adding a reactant or are we adding a product? Now see, in our equation given, heat is a product, right? So we add the heat, meaning we are adding more of the product. So if you add a product, what happened to the equilibrium? So according to the Le Chatelier's principle, it would adjust it so that what the disturbance will be lessened, all disturbance will be compensated, right? So if you add heat, then in order to get rid of that added heat, so it would go to the reverse direction. Okay, and then we will see, since it's moving to the reverse direction, what would be the correct choice from the choices given. And all of these are gases. The partial pressure of NO will increase, meaning if you go in the reverse direction, nitrogen monoxide is a product, right? So since it's a gaseous product, we can measure the concentration in terms of pressure. So the more of NO will be produced, the more NO gas produced means the partial pressure would be higher. So partial pressure of nitrogen monoxide will increase. That is a true statement. Let's look at the other one. All three partial pressures will increase. No, not all three. NO will increase, and since the reaction is moving reverse direction, what happened to the partial pressures of N2O? N2O and NO2 going to decrease, right? Because they are going to use up. So all three partial pressures will increase is not correct. And then the partial pressure of NO and N2O will increase. Yes, NO will increase, but N2O will not increase. This would decrease. Partial pressure of NO2 will increase. That's also not true because NO2 now, since it's going to the reverse direction, NO2 should decrease. Partial pressure of NO will decrease. So this is the product. The NO, it's not decrease, it's going to increase. Okay, that's how you approach these problems. Next one, methanol can be synthesized by combining carbon monoxide and hydrogen. And we are given the equation. And it doesn't tell us whether it is an exothermic reaction or an endothermic reaction, or it has not given us which side the heat is. But we are given valuable information to find that out by looking at the enthalpy. Enthalpy is given delta H enthalpy for the reaction, negative 90.7 kilojoules. Okay, now by the sign of the delta H, can figure out whether it is exothermic reaction or endothermic reaction. So when delta H is negative, is it exothermic or endothermic? What do you think? It is exothermic reaction. So in exothermic reaction, heat release delta H is going to be negative, right? The product's energy going to be less than the reactant. So the delta H, when you get it, it will become negative. So meaning this is an exothermic reaction. So in an exothermic reaction, where do you find the heat? Is it a product or a reactant? In exothermic reaction, heat is a product, right? So your heat going to be on this side plus heat. Okay, I'm going to write over here. So that would help you to finding out which side the heat supposed to be, and then you will see either by decreasing or increasing heat, which direction should it proceed. Okay. Now this one, heat is a product. What are they doing now? What effect will be seen when equilibrium is re-established after decreasing the temperature by 45 degrees Celsius? Now we are decreasing the temperature. So we are decreasing the temperature. What does that mean? So heat is in the product side. So we are making less of one of the products. We are reducing one of the products. So heat is going down. If the heat is going down, which direction should the reaction proceed to compensate the change that the reaction had gone through? If just like you are removing one of the products, so heat is being removed. So then the reaction should proceed to making more of what is being lost. Heat lost, so then it should go reverse. So which direction? Reverse direction, no, forward direction. Forward direction. So it should go to the forward direction, making more of the heat. Okay. Once you figure that out, then you can do look at the problems choices and then see what is the correct answer. Now we have carbon monoxide gas, hydrogen gas, giving you methanol gas. The partial pressure of methanol will decrease. So methanol is this guy over here, right? If the reaction moving forward direction, what do you think as the reaction proceed? Are we going to make more methanol or less methanol? More methanol. So then it's a gaseous product. What happened to the partial pressure of methanol? Increase or decrease? Increase, right? So A is not correct. So then the next one, all the partial pressures will decrease? No, not all of them. Only carbon monoxide and hydrogen partial pressure will decrease, methanol increase, because carbon monoxide and hydrogen being used up. So their partial pressure will go down. And then the partial pressure of hydrogen will increase. Hydrogen is again a reactant. Since it's going to use up, it's going to get lower. And D, the partial pressure of carbon monoxide will decrease. Carbon monoxide right here. What do you think about that? If the reaction is moving forward direction, carbon monoxide partial pressure increase or decrease? Decrease, right? So that's correct. D is the correct answer. Carbon monoxide partial pressure will decrease because it's going to use up. So the amount of gas in the vessel going to be decreased. As a result, the partial pressure of carbon dioxide will decrease. And then the last one, the partial pressure of hydrogen and methanol will decrease. Hydrogen will decrease, that's true, but the methanol should increase because it's the product. We are making more of that. Okay? Makes sense, correct? And number 12. Hydrogen bromide will dissociate into hydrogen and bromine gases. And we are given the equation. It doesn't tell us whether it is endothermic or exothermic, and also it has not put which direction heat should be. But we are given a valuable information, which is we are given the delta H enthalpy for the reaction. 68 kilojoules, which is a positive number. So if it is positive, is it exothermic or endothermic? That's going to be endothermic reaction. Delta H is positive, right? Meaning your products are high in energy compared to the reactants. Remember how we draw the potential energy diagram? So this is the energy and this is the reaction coordinate. So in a endothermic reaction, so your reactant come to the transition state and then the products. So reactants are going to be here, products are going to be here, and your delta H going to be the difference over here. So products have more energy compared to the reactants. So delta H going to be positive for a endothermic reaction, right? You guys have learned this already. And for exothermic reaction, you start your reactants, let me start a little bit higher. Your reactants are higher in energy and then your products are lower in energy. So your delta H is being calculated from the difference, energy difference here. So energy of the products is higher compared to the energy of the reactants. So your delta H going to be less than 0, meaning it's negative. That is a exothermic reaction. Okay, so here delta H 68, like here, let's say 68 kilojoules. Okay, so the difference. And what do you call this? This is your activation energy, right? Activation energy. Activation energy from here to here in this case. Activation energy. Not that little, not this one. Okay, you got it. So we talk about this in the previous chapter too. So this is the activation energy. Okay, just a little bit additional stuff to remember you what is exothermic and endothermic. Okay, now this is endothermic reaction. Now in an endothermic reaction, if a reaction is happening, heat is being absorbed, right? So which direction would you put your heat? So heat is a reactant in an endothermic reaction. Okay, endothermic reaction, heat is a reactant. Now, so then if you, okay, so let's see what's happening. What effect will a temperature increase of 50 degrees have on this system at equilibrium? So you increase the temperature by 50 degrees. So by increasing, what are we adding? Are we adding a reactant or a product? We are adding heat, right? So we are adding heat. If you add heat, if you add one of the reactants, which direction should the reaction proceed? You would proceed to get rid of the added heat, meaning by going forward direction, right? So the reaction will proceed making more of hydrogen and bromine by adding heat. Okay, with that in mind, let's see. So that the hydrogen and bromine partial pressure will increase, HBr partial pressure will decrease. These two will increase, right? We are making more of the products. Partial pressure of hydrogen bromide will increase. Is that correct? That's a reactant. No, right? There will be no effect on the partial pressure of any of the gases. That's not correct either. Partial pressure of hydrogen, bromide, and bromine will increase. Bromine will increase is correct, but the hydrogen bromide not correct. Partial pressure of hydrogen will increase, true, right? Hydrogen will increase because it's a product. So you are making more of the products, more hydrogen gases. As a result, partial pressure of hydrogen will increase. Need to know the initial pressure volume? No, that's not true either. So the correct answer is hydrogen partial pressure will increase. Okay. 13. Now, okay, number 13. Try to do these questions by you trying to do it without my help, and see if you can also come to the correct conclusion by logically thinking like this. Okay. Number 13, ethane can be formed by reacting acetylene with hydrogen. Under which reaction conditions would you expect to have the greatest equilibrium yield of ethane? So ethane is this guy over here, C2H6. Okay, and C2H2 is acetylene. That's why it says by reacting acetylene. Acetylene is this guy, and ethane can form. Ethane is this one. Okay. Okay. Under which reaction conditions would you expect to have the greatest equilibrium yield of ethane? So we're gonna see how can we maximize the product by changing the pressure and temperature. Let's see which conditions would favor. Okay, so we are given delta H of the reaction as negative 311. Okay, so now tell me whether it is an exothermic reaction or an endothermic reaction. Negative delta H, exothermic reaction, correct? So then where do you find the heat in an exothermic reaction? Reactant or a product? Product, right? Exo means you are releasing heat, so heat is a product. So plus heat. Plus heat. Now, how can we make more yield of your product? Okay, if you do it at a lower temperature, you are lowering the temperature. What would that happen? If you lowering temperature means you are lowering the heat. If you try to lower the heat, what would happen? Which direction would the reaction go? You are going to lose one of the products. So then the reactants will start reacting more, and it would proceed making more of the products, right? So lowering heat will proceed into the direction where you want to make more heat, right? So the forward reaction will take place. So does it make sense that the low temperature will give us more yield? Yes. If you add the heat, what happens is reaction will reverse it because you want to get rid of the added heat. Now lowering heat is, now it's exothermic reaction. You lowering the heat, the reaction will proceed to making more heat. So low temperature is a correct thing to do. What happens if you make a high temperature? If you make the high temperature, making the temperature increase, meaning you are adding heat. So then if you add heat, that's one of the products, reaction will go towards reverse direction. So then the ethane will start used up to give you the reactants. So then the product yield will not happen, right? So you do not increase the heat in an exothermic reaction to make more product. You have to lower the temperature. Okay. All right. So the next one is pressure. What happened? Well, how can we look at the pressure component? Now to look at the pressure, we have to look at the number of moles. Let's look at it. Remember, there is a relationship between pressure, volume, and number of moles. Now here we have 1 mole of acetylene, 2 moles of hydrogen, giving you 1 mole of C2H6. So basically 3 moles we have in the reactants, and then product 1 mole, 3 to 1. Now we want to make more of the products, right? How can we make more of the products? So we comparing it to number of moles. So we want to make sure the number of moles is n. Number of moles need to go down if you want to make more of the products, because the product has only 1 mole. So our goal is to lower the number of moles. How can we lower the number of moles? Remember the volume and the number of moles relationship. You can make less number of moles by reducing the volume. when the volume reduces, because the volume tells us the space or the volume that the number of moles takes. So less number of moles means we want to make sure volume is less. Now, what is the relationship between volume and the pressure? It's a Boyle's law. Lower volume means higher pressure, right? So it's a reciprocal relationship. Lower volume mean it has to have a high pressure. Okay. So that means if you want to make the reaction move forward direction, making less number of moles, you have to have a high pressure. So the correct answer would be low temperature and high pressure. Right? Again, if you look at it in backwards, by adding a high pressure, what happens? If you increase the pressure, what happens? The volume goes down. The volume goes down, then it has to make less number of moles. How do we make less number of moles? By going to the direction where it gives us a less number of moles, which is your products. Okay. So low temperature and high pressure. Okay. Got it? Awesome. I hope you got it. Okay. And listen to this explanation again if you didn't get it. It will make sense to you. Okay, so the next one is also similar to that. Nitrogen dioxide can dissociate to nitric oxide and oxygen. Under which reaction conditions would you expect to produce the largest amount of oxygen? Now this one is delta H given positive 114 kilojoules. Now tell me, is it going to be exothermic or endothermic? Endothermic. Where do you find your heat? Reactant or a product? It's a reactant, right? First thing you do it, you're going to go ahead and write down where the heat supposed to be. So heat is now considered as a reactant. Now let's see what's happening or what we need to do in order to get a higher yield. Under which reaction conditions would you expect to produce the largest amount of oxygen? So oxygen is a product. So we want to see what conditions will help us to propel the reaction forward direction, right? High temperature. What happens if you give more temperature, more heat? So you're adding one of the reactants. So if you add a reactant, you want to get rid of that added reactant. So which direction would it go? Forward direction. So there you go. We need high temperature. That's correct. And then what about the pressure? Again, similar to the previous one, we can look at the pressure terms by looking at the number of moles. So in our reactants, we have 2 moles. And in the products, how many moles we have? 2 here and then 1 oxygen. So 2 plus 1, 3 moles. Right? So by looking at the number of moles, we want a reaction to make more number of moles. And we need to increase the number of moles. And then we're going to correlate number of moles to volume. That is the Avogadro's law. The number of moles is directly proportional to the volume. So if you want to increase the number of moles, so then the volume need to increase. Now then we use the Boyle's law, which is PV is a constant, pressure and volume has a reciprocal relationship. The volume will increase by lowering the pressure. If you want to increase the volume, then the pressure needs to low. So meaning the reaction will proceed making more number of moles by lowering the pressure. So it has to be then high temperature and low pressure, isn't it? High temperature because it's endothermic reaction, and then the low pressure because we want to make more number of moles of your product. Okay, what happens at low pressure? When the pressure is low, volume need to go high. When the volume is high, number of moles increases. Number of moles increases in the direction where we have more now. So the reaction will proceed in the direction we can make more number of moles going from reactants to products. Okay, so the correct answer would be then high temperature and lower pressure. Okay, number 15. The following reaction is at equilibrium in a closed container. Which of the following will decrease the total amount of carbon dioxide gas present at equilibrium? Okay, Now let's look at the reaction substances, reactants. So this is a solid, this is a solid, and carbon dioxide is a gas. Remember that by adding solid, nothing happened to our equilibrium, right? Because only thing that you find in the Kc expression will have an effect on the equilibrium position. We only put gases and aqueous substances in our QC expression, not the solid or pure liquids. Remember that? Okay. Now let's see which decrease in the volume of the container. What happens when you decrease the volume? So again, volume decreases, and then what happens? Pressure increases. We don't have to worry about the pressure here. Volume decrease. When you decrease volume, what happened to the number of moles? Number of moles need to decrease. What is the number of moles in our reactant side? Only 1 carbon dioxide. Do we have gaseous number of moles in the product? No, it is 0. So correct, right? When you decrease the volume, meaning it has to reduce the number of moles. Now, which direction will it reduce the number of moles? By going forward direction. 1 versus 0. Right? So the more number of carbon dioxide will react to lessen the number of moles because we are reducing the volume. So first statement looks correct. Decrease in the volume of the container. Number of moles will go down. As you decrease the volume, carbon dioxide will start reacting. Okay? And adding more solid sodium hydroxide? No, because it's a solid, nothing happened. Adding nitrogen gas to double the pressure? Nitrogen gas is not going to react with any of those things. So because of that, that will not going to affect, right? So that will not have any effect on the equilibrium. Removing half of the solid sodium bicarbonate? No, because it's a solid, it's not going to affect for our equilibrium. None of these choices are correct. We do have a right choice. Okay then. That's about how Le Chatelier's principle affect the equilibrium constant and the equilibrium position and finding the yield by changing the volume, pressure, number of moles and temperature. Okay. I hope you guys understood what we went over these concepts, and you should be able to do your homework 3 and 4 now without any trouble. Okay. Have a lovely rest of the day. Bye for now.